Alrighty, so here we're going to look at some series and parallel circuits, okay, and looking at how voltage and current passes through these types of circuits. Here we've got the same cell on the right here with the light bulbs and the battery. Okay, this here is the battery over here, and these are our two light bulbs. What I'm going to do first is trace the way the current will travel around this circuit. So it's going to start, come out of the negative terminal, go through both those batteries and then back into the positive. What a lot of us are struggling with is the idea that this wire, I'm going to trace it in a marker of some variety, this wire here, okay, as we trace our way through, is full of electrons, absolutely full of electrons. And when we start applying the pressure on the circuit here, that pushes the electron that way and that pushes the next one and so on and so forth. And that continues until we get our current flowing through our circuit. Now, let's say the battery here is 6 volts. I'll do this in red, 6 volts. Undo, 6 volts. Okay, let's say we have a battery or a resistor here of 2 ohms and one of 5 ohms, just to make it a bit more tricky. So we've got a 5 and a 2 ohm resistors. Now the first step for any of these problems over here, the first step is to identify what our total resistance is. So step 1, find RT. Now because we have a series circuit, we know RT equals R1 plus R2, which means that 2 ohms plus 5 ohms is our RT, which is 7 ohms. So now we know that our resistance total is 7 ohms. We now need to find the only other unknown. Well, there's a few other unknowns. We can find the next unknown, which is our current, let's say. So we want to find our IT. Now, our IT doesn't change throughout the circuit because we have a series circuit. I'm just going to try and do this down here. So for our IT, we just need to use our Ohm's law, which is V equals IR. We know our V is 6 volts. Do we know our I? No, we do not. So we can put in IT if you'd like, or just leave it as I, times our resistance total, which is 7. So our I is going to be IT times 7 divided by 7 equals 6 divided by 7. Going to cancel those out. And we get I equals 6 over 7 amps, and I can leave that as a fraction. The last thing I need to do, if we go back to our diagram, is to find out how much voltage is used by each bulb here. And that again can be quite simply done by connecting our voltmeters there and using Ohm's law. So the first one I'm going to do is identify, I'll put it in highlighter. The first one I'm going to look at is my resistor 2, which is my resistor 1, which is that one. So to find the voltage through there, I'm going to go to a black pen. V equals IR again. I can put V1 equals R1 times IT, doesn't matter. V equals our voltage, we don't know. And I is 6 over 7 times our resistance, which is 2. So the voltage used up is 12 over 7 volts. And then the last one we're going to do, V2, is again I times RT, R2, sorry, not RT. We don't know our voltage, so we go V2 equals 6 over 7 times our second resistor, which is 5, which gives us 30 over 7. I'm going to guess that if you added 30 over 7 and 12 over 7, that you would get 6 volts. But let's not leave that to chance. VT equals V1 plus V2 in a series circuit, as we know. That's plus. Okay, we're going to check. VT equals V1 is 12 over 7 plus our V2, which is 30 over 7. And that's going to give us 42 over 7, which is going to give us 6 volts, which is the voltage we had initially. So we've just found all the components we need in that circuit there.